Hey folks, welcome to another installment of our mini fragment. In this one, we're going to talk about item 3 from Joshua Bloch's book, Effective Java. In case you don't already have a copy of this book, we'll add a link to the book in our show notes. You should absolutely get yourself a copy so you can follow along. Alright, item 3. Enforce the Singleton property with a private constructor or, wait for it, an enum type. Okay, let's start at the top. What is a singleton? Whenever you have a class that you only ever want to have a single instance of, then you use a singleton. In simple words, if you have a class lying around that you always want a single instance of, so you don't want multiple instances of this class being created, then you would make that class a singleton. In the world of Android, can you think about where a singleton is used? Well, the most immediately obvious one is the application context. In your app, you have a single instance of the application context that you access from different places. So that's an example of a singleton. Now, in this item, I want to make it clear, right off the bat, Joshua puts it up in huge bold letters, saying making a class a singleton can make it difficult to test clients. So when you follow along with this item, don't misunderstand it to mean use singletons more. If you ever do need to use a singleton, then you should consider these approaches to making those singletons. So that's how you should basically read this whole item. Okay, here's a Java pop quiz question for you. In how many different ways can you actually create a singleton in Java? If you said 2, then you're a venerable enterprise Java developer, just like I have been, who's seen the glorious pre-1.5 days. Well, the real answer is in today's world, the post-1.5 Java days, there are actually 3 ways to do this. But let's first dive in to the first 2 approaches because they're pretty similar and they're quite easy to grasp immediately. Okay, the first approach is inside your class. What you do is you create a public static final instance variable of the class. So basically you create a constant and you initialize it right away. In the examples that Joshua uses, he uses this class of type Elvis because, there's only one Elvis and the other Elvis sightings that are being made are spurious. I like this guy, Joshua. Okay, in any case, you create the public static final instance variable of the class and you initialize it right away. That's step 1. Step 2 is you actually privatize the constructor, which means you make the constructor private. The lack of a public or protected constructor guarantees, as he calls it, mono-Elvistic universe. So basically there's only one instance ever created. No more, no less. And nothing that a client does can change this. Because you've actually made the constructor private, you can no longer create instances of this class from the outside. Okay, and here's another side pop quiz question. If you privatize the constructor, is there really no way that you can create instances of this class? Well, if you're an advanced, shameless Java developer, then you know that using reflection, you can actually invoke this private constructor reflectively. You can use this method called accessible_object.setAccessible. It's talked of in more detail in item 53. So we'll worry about that a little later. But you should know that this is possible, but you can also defend against this attack. And the simple way to do that is basically modify your constructor to throw an exception if anyone asks to create a second instance. So that's the first approach. It's super simple. You have a public constant that's accessible from outside. The nomenclature is to usually call this instance. So because it's a constant, you use capital instance and you access this instance constant from outside. So that should make sense. The second approach is very similar to the first one, but you make some minor tweaks to this approach. So remember how you had a public static final instance variable, so the public constant in the approach 1. In the second approach, you basically make this constant private. So it's a private constant. Remember, the constructor is also private. So you have both of these private sort of things that live inside this class. Obviously, because it's a singleton, the whole point is to be able to access this from outside. What you do is you expose a single static method called getInstance that returns this constant. So it's sort of a nice wrapper API to this class. So whenever anyone wants to access this class from outside, they would call it getInstance. And if you remember from the very first item, this is very similar to a sort of factory method like call. Okay, so let's consider the pros and cons for these two approaches. Well, with the first approach, it's super simple and clear that there's a singleton because there's this constant variable that sits right at the top of your class. So anyone who reads the class immediately understands that this is a singleton. So that's an advantage for the first approach. The advantage with the second approach is that because it's inside this wrapper public static class, if in the future you change your mind about this class being a singleton and, for some reason you decide, hey, it's okay to have multiple Elvis instances, then without really changing this API, it gives you a convenient way to sort of change that behavior. So whenever you call the getInstance factory method, you can basically create a new Elvis and return this. So this is just something to consider. In the future, if you did want to change your mind, the second approach works well. Another point that might come up is that with the first approach, because you're not necessarily using this factory method, maybe it's more efficient because you have direct access to the variable. And especially in the Android world, adding more getters, setters, nested methods is looked at as a disadvantage because it's basically adding more layers to the stack. What he says in the book is there no longer is any performance advantage to just the public field because most JVMs almost always inline the factory method call anyway. So when it gets compiled down, they're inlined anyway. So the performance advantage is not seen. Obviously, as an Android developer, you can't really trust any of these things, and you have to confirm for yourself if the Android JVM does the same thing. I'll add actually 2 Stack Overflow links where someone has basically asked the same question. So the long story short is, yes, these do happen in Android. I want to, however, point out that generic getters and setters are a little different. They don't necessarily get inlined, and at least that's my understanding. However, that behavior changed in Gingerbread. So assuming you support something before Gingerbread, nobody should be supporting anything before Gingerbread. Past Gingerbread, they added simple inlining for getters or setters, and a person from the Android team who's actually worked on the Dalvik responded in the Stack Overflow answer. So that is definitely a credible answer. And it was funny because it's not as optimized as you would expect. But granted, this is quite some time back. And I also remember listening to ADB sometime, the show on their art compiler, where they say with the art compiler, a lot of these optimizations have been added in. So the whole long story short, you don't have to worry about this. This is no longer an advantage. So what Joshua says applies to the Android world. Here's another consideration. What if your class had to implement serializable? Merely adding implements serializable won't really cut it because with singletons, what happens is each time the serialized instance is deserialized. So if you've written it to disk and then you're reading the data from the disk and trying to recreate your object, a new instance will always be created. So this is a perfect recipe for spurious Elvis sightings. What you actually have to do in order to prevent this, by the way, also a great Java pop quiz interview question, declare all the fields transient and provide a readResolve method. Now this is talked about again in item 77, so remember to stay tuned and we'll touch this topic again. As of release 1.5, so this is Java 1.5, there's a third approach to implementing singletons, and the answer is enums, baby. That's right. That cool kid that's constantly spurned by the makers, but loved by the public at large. It's almost like the Mockingjay of the Android world. You can use enums to create singletons. If you look at the API for creating enums in Java, it'll become clear. The approach is basically to build a single element enum type. And within this enum, you can have your other methods. And this approach is functionally equivalent to the first approach, except A, it's more concise. B, it provides this whole serialization machinery that we just talked about for free. And it provides an ironclad guarantee against multiple instantiation. So even in the face of some type of really complicated and sophisticated serialization or reflection attacks, your enums will guarantee that the object that you want as a singleton will totally work. So Joshua winds this item down by saying, while this approach has yet to be widely adopted, a single element enum type is the best way to implement a singleton. Little does Joshua know, us Android developers, we are all over that good stuff. We use enums all the time. That's right, I said it. All the time, because enums matter.